Lattice energy. My dear students, our brother, today we will be talking about lattice energy, okay? What is lattice energy? In a chemistry, okay? Then lattice energy is generally defined as the energy released in the formation of 1 mole of an ionic solid from its gaseous ions, okay? Lattice energy, the energy the energy released in the formation of in the formation of in the formation of 1 mole of an ionic solid from its gaseous ions from its gaseous ions, okay? Na positive plus Cl negative in gaseous, that is sodium chloride solid plus energy U, okay? Where U is the lattice energy. Where U is the lattice energy. U is the lattice energy. Okay? It is the characteristics properties of ionic compounds. In other words, when 1 gram mole of ionic solid or when 1 gram mole when 1 gram mole of ionic solid of ionic solid 1 gram mole of ionic solid is formed mole. In other words, when 1 gram mole of ionic solid is formed from the cations and anions brought from an infinite distance to an equilibrium distance, okay? Equilibrium distance. The energy released is called lattice energy. The energy released is called as lattice energy. Okay? When 1 gram mole of ionic solid is formed from the cations and anions brought from an infinite distance to an equilibrium distance, the energy released is called the lattice energy. It is denoted by U or U naught. It is denoted by U or U naught. U or U naught. Mathematically, it expressed as U naught equal to ANZ plus Z minus E square upon R naught 1 minus 1 upon N. This equation is called Born-Land equation. This equation is called Born-Land equation. Okay, where each electronic charge, capital N is Avogadro number. Avogadro numbers, and Z plus charge on cation, charge on cation, charge on cation, and Z minus charge on anion, charge on anion, and A is a Madelung constant. A is a Madelung Madelung constant, okay? And R not equal to R plus R. R plus R, internuclear distance between cation and anions. Internuclear distance between cation and anion, okay? Capital N be the Born exponent, okay? N is related to repulsion between the electron clouds of the positively charged ions. The value of N depends upon the electronic configuration of inert gases. Value of N. For helium 5, for neon 7, for argon 9, for krypton 10, and for xenon 12. Okay? 5 for helium, the value of N is 5, and for neon, the value of N is 7, and for argon, the value of N is 9, and for krypton, the value of N is 10, and for xenon, the value of N is 12. Okay? For sodium chloride, that means salt, namak. Okay? For namak, that means salt, sodium chloride. For जिस नमक को हम लोग घरों में यूज करते हैं उसका फार्मूला है NaCl, एंड उसको माना जाता है सोडियम क्लोराइड. ओके, सोडियम क्लोराइड, जिस नमक को हम लोग खाते हैं उसका नाम है सोडियम क्लोराइड, NaCl. दैट मीन्स फॉर NaCl, Na positive approximately neon and Cl negative approximate argon. The value of N equal to 9 plus 7 upon 2, that is 16 upon 2, that is 8. Okay? Lattice energy can also be defined as that energy required to break down, that energy required to break down, that energy required to break down 1 mole of the crystal, 1 mole of the crystal into free constituents gaseous ions, that is MXH plus U naught, arrow mark of capital M plus G plus X negative G. Gas. G means gas. Okay? Factor affecting lattice energy. Okay? Which factor affects the lattice energy? Factor affecting lattice energy. Factor affecting lattice energy. Okay? Factor affecting lattice energy. For size of the ion. First is size of the ions. Size of the ions. It varies universally as the internuclear distance are not between the oppositively charged ions in an ionic crystal. Thus, larger the size of the ions, lower will be lattice energy. Lower will be lattice energy. Okay. Then U naught NaCl is the greater than U naught KCl because R sodium is the greater than R sodium positive ion is the greater than R potassium positive ion. Okay. It varies universally as the internuclear distance varies universally as the size of the ions. Okay. Factor affecting lattice energy. Lattice energy is universally proportional to size of the ions. Size of the ions. That means it varies universally as the internuclear distance are not between the oppositively charged ions in an ionic crystal. Thus, larger the size of the ionic, lower will be the lattice energy. Okay. It varies universally. It varies universally as the internuclear distance are not between the oppositively charged ions in an ionic crystal. Thus, larger the size of the ions, larger the size of the ions, lower will be lattice energy. Lower will be lattice energy. Second, charge on the ions. Charge on the ions. Second, charge on the ions. Okay. Charge on the ions. It varies directly as the product of the charges and the ions of the crystals. Thus, greater the charge on the ions, more is the lattice energy. Thus, the lattice energy of the ionic crystals containing bivalent and bivalent are in the order LiF. Lithium fluoride is less than Ca. Calcium fluoride is less than magnesium sulfide. Okay. Then it varies. Charge on the ions. Lattice energy is varies. Okay. It varies directly. As the product of the charges. Product of the charges on the ions of the crystal. On the ions of the crystal. Of the crystals. Okay. Thus, greater the charge on the ions, thus greater the charge greater the charge on the ions, greater the charge on the ions, more is the lattice energy, more is the lattice energy, more is the lattice energy. Thus the lattice energy of the ionic crystal, thus the lattice energy, thus the lattice energy, thus the lattice energy of the ionic thus the lattice energy of the crystals, ionic crystals containing containing univalent example Li lithium positive and fluorine negative ion unibivalent unibivalent that is calcium double positive ion and fluorine double negative ion, okay, and bivalent and bivalent that is Mg plus 2 ions and S minus 2 ions are the order of lithium fluoride is the less than calcium fluoride is the less than magnesium sulfide, okay. Packing of ions. Next is third point, packing of ions. Third point, packing of ions. Third point, packing of ions, okay. Packing of ions. Third point, packing of ions, okay. Third point, packing of ions. Packing of ions. Packing of ions, okay. The more compact is the packing of ion, more is the lattice energy. The more compact is the packing. The more compact is the packing of ions, more is the lattice energy. More is the lattice energy. More is the lattice energy. Fourth point, effective nuclear charge. Fourth point, effective nuclear charge. Okay. Effective nuclear charge. More the effective nuclear charge, more is the lattice energy. More the effective nuclear charge, more is the lattice energy. More is the lattice energy. More the effective nuclear charge, more is the lattice energy, okay. Then U naught AgCl is greater than U naught potassium chloride, silver chloride. U naught chandi, silver means chandi. U naught silver chloride is greater than U naught potassium chloride H. Z zinc silver and is greater than zinc potassium. Okay. It is observed that higher the lattice energy of an ionic solid, greater is the stability. The lattice energy of the ionic solid is high because the ions are held together by strong electrostatic forces of attraction, thus due to which ionic compounds are comparatively more stable. Ionic compounds are comparatively more stable than lattice energy of some ionic compounds. Okay. In practice, lattice energy of ionic solid are obtained by Born-Haber cycle. Okay. Energetic of the formation of ionic compound. energetic of the formation of the energetic of the formation of ionic compound, energetic of the formation of ionic compound. Okay, let us consider the formation of sodium chloride from sodium solid and chlorine gas. The following steps are involved in the formation of sodium chloride from sodium chloride. Okay, sodium solid in solid state is arrow mark of sodium in gaseous state, delta HS positive, delta HS positive. Sodium gaseous state, that is sodium positive ion in gaseous state plus electron, that is ionization potential positive. Okay, and 1 by 2 chlorine gas in gaseous state or chlorine in gaseous state, that is 1 by 2 delta HD positive ion, and chlorine gas plus electron is chlorine negative in gaseous state, that is EA negative, and finally Na gaseous state plus Cl negative gaseous state, Cl negative gaseous state is arrow mark of NaCl in solid state, NaCl in solid state, that is Na solid state plus 1 by 2 Cl2 gaseous state, arrow mark of Na positive ions, Cl negative ions in solid state, and delta HF negative, okay, delta HF negative, because this is negative U. Okay, those in the formation of sodium chloride of energetics involves are: first is sublimation. Thus in the formation of sodium chloride in solid state, energetic involved are: first point, sublimation energy, delta HS. Second is ionization potential, ionization potential IP, ionization potential IP. Dissociation energy, delta HD. Third is dissociation energy, delta HD. And fourth is electron affinity, EA. And fifth is lattice energy U, Okay, energy is absorbed from first, second, third, and released in energy is absorbed. Then energy is absorbed in first, second, third, and released in fourth and fifth. The energy released compensates more than the energy absorbed, and as a result, delta HF heat of formation, delta HF heat of formation, delta HF heat of formation, is negative, and sodium chloride is formed, and sodium chloride is formed. इसका मतलब कि नमक सोडियम और क्लोराइड से बनाया जा सकता है. ओके, thus formation of sodium chloride is controlled by formation of sodium chloride Na positive ions and chlorine negative ions is controlled by delta HS IP ionization potential, delta HD EA and U, then minus HF equal to delta HS plus ionization potential plus half of HD minus electron affinity minus U lattice energy. Okay, next heading is Born-Haber cycle. Okay, Born-Haber cycle.